Hi, everyone. I'm Seth Vargo. I'll do a little introduction. Cool. Welcome to TDDing tmux. It's like a cool name, right? It's like an alliteration. It's fun to say. And everyone loves alliterations. So how many people in here consider themselves like Rubyists or developers by a show of hands? It's cool. A little over half. How many people consider themselves like operations people or like ops people? Cool. How many of those Ruby people test their code every day or every time they do something? That's cool. That's like 99.99%, right? How many operations people test their code? That's like 3. Cool. So the whole point of this talk is all about that. So you should make friends with those Rubyists because everything that I'm going to tell you today is the stuff that they're already doing for their existing code. If you need help making friends, there's a really good article on WikiHow. So what is this talk really? I couldn't fit this on the slide, but it was how to apply the testing stuff you already know in Ruby to Chef, because Chef is just Ruby, and yeah, the rest of that. So I'm Seth Vargo. You may recognize me by my familiar red-faced avatar, but I now work for OpsCode, so I have this beautiful OpsCode black and white avatar. So like I said, I work for OpsCode. I'm a solutions engineer. I lead our Learn Chef campaign, and I also hold all of our office hours for newbies. So if you want help with Chef, you should come talk to me. And shameless plug, we're hiring. So if you're interested in anything, head out to opscode.com/careers. So let's talk about testing, because that's what you came here to talk about. As with any great project, it starts on GitHub. So we're going to look at the OpsCode Chef repo. It's just github.com/opscode/chef repo. And it looks like this. This is your standard Chef repo. If anybody has ever looked at a Chef repo or seen one before, you have a bunch of very common files and folders, and Josh writes all of them. So we're going to clone this to our local machine. I was going to live code this, but as you all are aware, the Wi-Fi is like spectacular, and I have to download gems, so this is now a slide deck. Sorry, Sasha. So the first thing we need to do is make a gem file. If you aren't familiar with gem files, this is just like Bundler's way of managing dependencies. And we're going to add a few things. So the first thing that we're going to add is Chef. Chef is like infrastructure as code, automation. I get paid to say that. You can use Ruby code to basically configure your servers. You can manage one server. You can manage a bazillion servers. It's pretty awesome. You should use it. Puppet's cool, too. So chefspec, as you may have guessed, especially for the Ruby developers, chefspec is RSpec testing and RSpec testing syntax for your Chef cookbooks. So it's the same syntax that you're already used to, but it actually runs Chef in memory and then reports on the results. In reality, it's like a major hack. It just like injects itself into all of your resources and makes sure that they ran. But it's really cool because it works. The next thing is fauxhai. So chefspec lacked like this critical component, which was node attributes. So under the hood, Chef uses ohai, O-H-A-I, which is this awesome tool that basically spits out your provisioned system as JSON data. And you can use that. It contains everything from like your users to your IP address to like pretty much everything that you want to know about your system. And you can use that as like a third-party tool outside of Chef. Well, the problem is chefspec expects certain attributes to be defined, especially like node-specific attributes that are like Ubuntu versus CentOS. And there's no easy way for you to do that unless you want to type out like 300 lines of JSON in every test. And that's not fun. Who wants to do that? Nobody. So I wrote fauxhai back when I was an intern at Custom Ink, and the idea was, in my like imperialistic view of the world, was that like we're going to have like open source system data, open source ohai data. And it actually took off at Chef Summit. So we have like a bunch of different operating systems that you can pretend to be in a test. So you can pretend to be a Windows machine on your OS X box. You can pretend to be an Ubuntu instance with multiple different versions on your like other CentOS box, which is really handy for testing, because if you're unit testing against an Ubuntu instance and your cookbook behaves differently on an Ubuntu instance than it does on a CentOS instance, you need to be able to test that. And you don't want like 15 laptops sitting on your desk all running different operating systems, because that's expensive and you don't have that big of a desk. Another tool that we're going to talk about is foodcritic. How many people are familiar with like JSLint or Cane? Any of those tools? So foodcritic is that for chef cookbooks. It's nothing more than a linting tool. It's actually like an ever-growing project. Andrew Crump just released a new version. So there's like all kind of rules. Etsy is really big into contributing. They have a lot of great rules out there. It's basically just like common pitfalls, common mistakes that you can avoid by following the simple rules that the linter gives you. Another tool I'll talk about a little bit in depth more is Strainer. It's like a sandboxing isolation tool, so you can move a cookbook into an isolated environment, run tests against it to see how it behaves like idempotently and like on its own with no other interactions, which is especially important in like unit testing because you don't want any of those third-party factors influencing your tests. And then the last thing we're going to talk about is guard. A lot of the Rubyists are probably familiar with guard, but it's really just a command line tool it's kind of a command line tool, but it watches the file system for modification events, and anytime you like save a file or update a file, you can tell guard to like do a trigger, and you define that trigger based on like regular expressions. So it allows you to like watch your files, so you can have a terminal in like one window and like code in another window, and as you save, it runs your tests. It's like super awesome. So let's kind of get started here. The first thing you need to do is obviously create a cookbook. This is TDDing tmux, and we're going to make tmux, obviously. How many people don't know what tmux is? Terminal multiplexer. It's cool. You should try it out. It has lots of features, like allowing 2 people to code at the same time in a remote session. You can keep it open. I'm not going to talk about tmux. Cool. So the first thing that we need to do is create a blank cookbook. We're going to use knife for this. That's a CLI for chef. So we issue a simple command. It's knife cookbook create and the name of the cookbook, in this case tmux. This is very similar to like Rails new whatever app name or like gem new whatever gem name. And that's going to create a scaffolding for us. It's going to give us some output and say like, hey, we created all these files. And if we go and look at those files in our editor, we'll see a bunch of folders and a couple files, some metadata and whatnot. And this is standard, just like out of the box with a chef install. But it turns out we don't really need like half of these. So we're just going to get rid of them to make things simple. So we're going to be dealing with like attributes, recipes, and templates, and some other files. So the first thing that we want to look at is the metadata. You always, anytime you make a new cookbook, this is like the first thing you want to do, just like the first thing you want to do whenever you make a new gem is edit your gem spec and add all your author information. So do that, change the version number, add a description if you really want to. The next thing we're going to do is, because we're doing test-driven development, is we're going to write specs. So we've generated our cookbook scaffold, and we only did that because our specs live within our cookbook. Everything else we're going to do after we write our specs, so that we can write the specs, watch them fail, write the code, watch them pass. So the first thing we're going to do is make a spec helper at the root of our chef repo. And all we're going to do is require chef spec. So you may say, well, why don't you just require chef spec at the top of every file? Well, the spec helper is a common pattern. Some people argue that it's an anti-pattern. That's up to you. He's shaking his head. But essentially, this allows us to share like our spec configuration across our project. So maybe we want like variables that are available to everything. Maybe we want to change the path that things are running. If we're going to use like Cucumber and Aruba, like help you later, but like it just keeps all the configuration in one file, and it makes all of our tests. All we have to do is require a single file at the top. It's like introducing a single point of failure, but in a good way. So like I said, it's totally unnecessary. You could require chef spec at the top of every file. You can even pass like a -r flag to rspec to make it require it during the run. So the first thing we're going to do is make our default spec. So this is going to live in the spec directory, default spec. It's common practice, and you'll see why in a little bit, to name the spec, the first part of the spec without the underscore, to the name of the recipe. So this is going to correspond to the default recipe. If your recipe was like foo, you would name it foo_spec.rb. And that's just so that as a developer, you can match them up, but we'll also see that comes in handy with guard later down the line. So let's write our first test. So the first thing we need to do is create a chef runner, and we do that this way. There's multiple ways to like create variables. You can make an instance variable in a before block, but I prefer to use the let because it's lazy loaded in rspec. And this is the syntax for creating a new chef runner. So it's namespaced under chef spec. I make a chef runner, and I converge on the tmux cookbook. And that tmux : default is like the chef syntax that's saying the tmux cookbook and the default recipe. I could have left out default, and it would have assumed the default recipe, but I wanted to be explicit here. So we now have access to this runner object, and we can write our first test. So simple RSpec syntax. It's going to install a tmux package. That's what we want it to do, install a tmux package. And we're going to use the new RSpec syntax because it's better than the old one. So we're going to expect the runner to install this tmux package. Super straightforward, like very English-like. You could have a non-technical person read this and understand what's going on. And the output, which you'll see in a little bit, is even more like straightforward. So a technical person, like a product manager, or a non-technical person, like a product manager, or your grandma, could come along and read this and know what's going on. And then we also want to drop our own configuration file in here so that we can manage like all our keyboard shortcuts and our keyboard bindings, because that's what tmux is cool for. So you may be asking yourself, like, what? Like, where did all of these things come from? Where did like install package and create file and this runner come from? And the answer is this incredibly long GitHub README that contains like all of the information that you would ever need to know about chefspec. Please don't try to read that. You'll get a headache. But you can see, like, as you're going through there, there's literally tons of matchers that you can choose from. And every like internal chef resource is mapped to an RSpec matcher, and then there are other custom ones and like third-party ones that you can plug in to chefspec that allow you to test like third-party things. So if somebody else is exposing an LWRP, they probably have like an RSpec provider that you can hook in and test that LWRP with like a custom matcher. And it's RSpec, so you can also write your own custom matchers. That's what makes it awesome. Anyway, chefspec has amazing documentation. If you're looking for like a project to model your documentation after, look at chefspec. It's really interesting because one of the big complaints when it first came out was like the documentation sucks. And Andrew spent a lot of time and a lot of energy like making sure that it's like centralized and very understandable and very human readable. So definitely look at it for like no other reason than it looks cool and is like really easy to understand. And there's a ton of examples. Finally, the last thing we're going to do is make a reference to an 80s song and then cross it out and put color above it because I want color. So I'm going to add to my .rspec file, which is just like a top-level configuration file for my rspec things that I want color for no other reason than like I have OCD, and like if it's not in color, it really bothers me. So we can run rspec with the simple rspec CLI. If you're using bundler, you might like prefix this with bundle exec or bin stubs or whatever you want to do. And we pass it the path to the default spec. And we can see, hopefully, like it failed. That's good, it failed, right? Like we don't have anything, it should fail. But if you actually read this error message, it doesn't make any sense. It says like cannot convert symbol into integer, like blue pill attributes default. Like what is going on? I have not, this is the first time I've mentioned blue pill in this talk. Like where the hell did blue pill come from? Well, it turns out during its convergence stage, chefspec is going to pull in all of your cookbooks. And blue pill also happened to be in my cookbook path of this repo. And it's expecting certain attributes that are defined. I think in this case, it's like the path to the Ruby. And those aren't defined by chefspec because they vary on system to system, which was like precisely the reason that I set out to write fauxhai. I have like an obligatory meme because this is a DevOps talk. So like I set out to like capture all of the machines and defeat all of the evil like provisioning beasts that exist. So when fauxhai first came out, it was like a separate gem, and like people were contributing JSON files via pull requests, and it was really cool and it was really awesome. And then Andrew and I got together at Chef Summit, and we talked a little bit, and then we talked offline, and we said, well, wouldn't it make more sense if like this was part of chefspec? So this is what you used to do. In a before block, you would mock out a platform, and this is just how simple fauxhai is. You mock out an Ubuntu platform version 12.04 or version 12.10. That can be like Windows version XP. It's like super straightforward. You know exactly what's going on. And then you would create a chef runner, and fauxhai would basically hook into the initialize method of your chef runner and inject JSON data into the node, which was like really hacky. So we came up with a better way, which was to put it inside of chefspec. So now you create a new Ubuntu 12.04 node, and then you converge it. So now it's even more straightforward to use fauxhai in your projects because you probably don't even know you're doing it. And as fauxhai gets updated, chefspec automatically inherits all of the new platforms that it gets. So like if you have Red Hat and you want to donate Red Hat provisions, you should come talk to me because we could use them. So this is what the rest of our test looks like. basically copy and paste from what we had before. So we are now mocking at Ubuntu 12.04, which means I get all of those attributes that I didn't have to define, like where is Ruby, who are these users, what's my IP address, and all of that's like stock data that fauxhai like makes up for you when it makes up the JSON file. And the same test as before. And you can see we're still converging the default recipe. So now if we run our tests, we get real failures because we still haven't written our cookbook. And we see like no package named tmux with action install found, no resource named etsy tmux.conf with action create found. So that means we didn't tell it to install the package, and we didn't give it a file to write. So this is really cool. So now we can set up guard so that we can write our cookbook and watch our test pass. How do we set up guard? Well, it's already in our gem file. We already have a bunch of guard hooks in there. So all we have to do is run guard init, and that's going to make a guard file for us. And we're going to get cool output that says writing a new guard file to whatever path your app is in. And it's going to look like this. So we're guarding rspec because we're using chefspec. And for whatever reason, rspec doesn't understand where specs live, so you have to actually pass the specs path when you're doing like chef-specific things. It gets it in Rails, it gets it in like pure Ruby projects, but it doesn't recognize chef's path to specs. Chef's specs path to specs. So the first thing we're going to do is watch that like anything that is in like a spec directory and ends in _spec. And the next thing we're going to do is watch that global spec helper. And whenever we watch, like when we see a change to that spec helper, we want to run all of the specs. Because most likely you changed like an rspec configuration, you required a new file, you added a global variable, so you could be breaking things. So if you change that spec helper, you want to run all of your tests. The next thing we're going to do is we're going to map a specific cookbook to its associated spec. And I'm sorry that this is an ugly regular expression, but it's a regex. Cool. So anything in the cookbooks directory, then we're going to capture the name of the cookbook. That's what that first capture is for. And then any recipe, and then the recipe name. So this would be like cookbooks, tmux, recipes, default.rb, and we've captured tmux and default. And we're going to run cookbooks, the name of that cookbook, which is tmux, spec, and then the name of that recipe, which was default_spec.rb. So that's why it was important earlier when I said that like we match the name of the recipe to the actual spec that's running. So we can use guard to like associate whenever one file is saved to run the associated spec. And similarly, like whenever anything is saved in the cookbook, run the associated specs for that cookbook. So this last one says, like, if I modify an attribute or if I modify a template, like, let's rerun the specs. So this is really cool because we're mapping like a recipe directly to its spec, but then anything else that we change, we need to run all the specs because we don't know what might break if we delete a template or change an attribute. So we run guard, and guard is just guard in your terminal. And we'll see something along these lines. It takes like 2 or 3 seconds for it to like initialize. Then it's going to say, hey, I'm watching your chef repo, and I'm going to run all your specs because you told me to run rspec, and then we're going to get the exact same failure messages. But you're not going to regain control of your terminal. It's going to hang there, and you're going to be like, what is going on? I want to type. But that's because guard is actually listening in the background to file system changes. So if we go and save a file or add a new file to our repo, guard is going to run our tests again, because it did that mapping that we saw earlier in the guard file. So this is like true TDD. So let's make our default recipe. This is in recipes default.rb. And we're just going to use Chef's default package provider for tmux. So it's package tmux. And we're going to go ahead and drop the template. So this is like a super simple recipe. We're coming in at like 5 lines of code without comments or white space. And all we're saying is write out etsy tmux.conf with this source file. Should be 644, install that package. And Chef will execute these in the order that it receives them, so you never have to worry about like it dropping off the template before the package is installed. So if we save that file, and all we have to do is save it in our editor, we'll go back and look at our terminal, which was running in another window or another monitor, and all the specs passed. That's awesome. That's great. Does anybody see what's like wrong with this situation, though? Yeah. Yeah, so I haven't made a template yet. It doesn't exist yet. So why do my tests pass? Well, this is kind of like one of the gotchas of chefspec and the way that it injects itself. So we told chefspec in our test that we want to create a template. We want Chef to run a template resource. And chefspec listens for that template resource. So literally, all it listens for is that you called template with that path. It doesn't actually execute the resource because it found it. It says, hey, like, I want to be fast. I'm a unit test. Let's move on. Well, the problem is, because it's not actually running your code, you don't know like, that template doesn't exist. So the way that we fix that is to actually test the content of the template we're writing. So we can alter our test to expect the runner to create a file, and that's what we were doing before. All we have to do is add with content, and that's a chainable feature of RSpec, and give it the first line of the file, or you could totally put the whole content of the file in there. And this is really powerful because it gives you the ability to make sure your templates are being written out properly if you're putting variables in there or like grabbing node attributes. Super awesome. And this is like a partial regex match, so you can match any line in the file, which is super cool. That's really confusing that like you can pass a chefspec run, but it's not actually going to pass a chef run, which is why we're going to look at some other tools in a little bit. So if we add that, we're going to see like, oh, there's no template name tmux.conf found in any of the default locations. Chef 11, this output has changed a little bit, but it's still going to give you a very similar error message. So we'll drop that conf file in. I stole this from the interwebs. We're going to put it in templates default tmux.conf, and we're going to run guard. Well, guard has been running. When we save that file, we're going to get all the examples of finished in like microseconds. That's cool. We're awesome. We have like successfully done test-driven development on a cookbook. Who's excited? Woo! Cool. So the next thing we need is more tests, right? Because like, what is a talk without more testing? But we're not going to do unit tests anymore because we've like pretty much exhausted the unit tests for this cookbook, aside from the fact that we've only tested on Ubuntu 12.04. Let's talk about some other things. Let's talk about foodcritic. It's especially important that we're like linting our code, especially if you're working in a team or like putting this cookbook out for other people to use in the community, accepting pull requests, etc. Let's run foodcritic. It's in our gem file, so all we have to do is say foodcritic and give it the path to the root of the cookbook, cookbooks tmux. And you can even include arbitrary rules. So like Etsy and Custom Ink all have their own rules. You can write your own organization rules. It's really cool. It just uses an AST. And if we run that, we're going to get FC045, consider setting name, attribute, and metadata, whatever, blah, 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 blah. You can look this up online on the foodcritic docs, and it gives like a huge explanation, awesome documentation about what FC045 actually means. In this case, it actually means we haven't set the name attribute in our metadata. One of the things that's really confusing about foodcritic is that it always exits with status 0. This really sucks if you're doing something like on Travis or Jenkins where like you're checking the exit status of a process to see if it succeeded or not. Well, you have to pass an additional flag to chefspec, the -f any or like --fail any, so that foodcritic will exit with a non-zero status if it fails. It'll exit with 0 if it succeeds. It's a little weird that you have to pass an extra flag, but keep that in mind if you're using foodcritic, especially on CI. So let's go ahead and fix that. We'll add that name attribute right there. It's just tmux. It's super simple, and those foodcritic tests will pass. The next thing we want to do is knife cookbook test. This is part of knife, which is, again, the CLI for chef. This will test not only our Ruby syntax, which chefspec would have gotten, but it'll also check like those missing templates and like things that we're referencing that chefspec may not have caught. So it's always important to run knife cookbook tests. Kind of sucks because it can be the slowest of all your tests, but definitely run it. It's going to check the cookbook, make sure you have valid syntax, make sure you have the files you're referencing, and the templates you're referencing. Super straightforward, but now it kind of sucks. Like, we have to run chefspec, we have to run, which we're doing with guard, we have to run foodcritic, which we're doing with guard, and we have to run knife, which we're doing with guard. But like, that's a lot of stuff to remember, that's a lot of commands to type in your guard file, it's kind of annoying. So we should probably simplify this process. It would be great if I could like run a single command, which would spin up my guard with all of my tests, and I could just work. So like I said, we have these 3 tools. There's a lot of other tools out there, like Chef Mini Test Handler and a bunch of other stuff that you might want to use for testing. And how do you use them together? And how do you share that code with other people on your team? So while I was at Custom Ink, I came up with this idea of Strainer, which is a Ruby gem that handles this problem. It uses a foreman-like syntax for a strainer file that allows you to define arbitrary tests with 2 environment variables that you can pass in. And then you can execute them by running strainer test and give it the name of a cookbook, and it will sit here and hang. And when you save a file, it will run all of those tests again. That's really cool. If you don't think so, I think it's cool. That's really cool because it gives you this added bonus. Not only can you work in a team and share this and easily decide which cookbooks are getting tested with which testing frameworks, but you can put it on CI. So this is specific for Jenkins, but you can do something similar with Travis or Circle. If you create a script/CI at the root of your chef repo, and you add this, which is basically clone my chef repo, and then run strainer test and setout _ cookbook, what you can do is copy this job a bunch of times, and all you have to do is name it tmux _ cookbook and foo _ cookbook, and it will run the appropriate tests for that cookbook. So you don't have to pay for 500 private repositories for each of your cookbooks, or public repositories if that's how you roll. You don't have to try to manage all of these things with Git and have a bunch of different Git remotes in your Jenkins configuration. It's one script CI that's checked under version control in one repo that's managed by Jenkins. And you can do quirky things like point it at the same code base so you're not always downloading the same workspace, so you're not always downloading the same chef repo a million times and taking up disk space, but disk space is cheap. Cool, so that's pretty much all I have to talk about TDDing and testing. I do want to show you guys this because this is my new introductory slide. I decided to go all designy on this one, but cool. You can find me on Twitter. You should follow me on Twitter. That's also my GitHub handle, but I couldn't find a good GitHub icon that was free. I work at Opscode. That's my email. If you have any questions, you can ask me now or email me. Cool.